Hi, I'm Megan, and today I'm going to be showing you how to solve simultaneous equations. Starting off with linear simultaneous equations, these are simultaneous equations with two unknowns which have a set of values that will make a pair of equations true at the same time. To find the value of x and y, we need to either add equations together or subtract them so that we can eliminate one of the values, either x or y. In order for this to work, we need to eliminate one of the values from the equation. So in this example, we need to either make the x is the same or the y is the same, so that when one equation is subtracted from the other, we will be left with either x's or y's and a number, so we can figure out the value of these. So for this example, I'm going to times the top equation 7x plus 3y equals 16 all by 3, so that there is a 9y in each equation. Timesing the top equation by 3 will give me 21x plus 9y equals 48. I am then going to subtract the second equation, 2x plus 9y equals 29, from the new equation to eliminate 9y and find out what the x value is. This is going to leave me with 19x equals 19, meaning that x equals 1. We now need to find the y value that is true for this set of equations, and to do this we need to sub in the x value that we have found into one of the equations. So I've chosen to use 7x plus 3y equals 16. So I need to sub in the 1, so it's 7 times 1 plus 3y equals 16, which gives us 3y equals 9, meaning that y equals 3. So I've gone through an example where you subtract one equation from the other, and now I'm going to show you how to add equations to find the value of x and y. As you can see in this set of equations, for the y values, one is negative and one is positive. This means we need to add the equations together to eliminate these values. To do this, we need to make sure the number is the same to eliminate the value from the equations. So in this case, we need to times the top equation by 3 to get 9x minus 6y equals minus 18, and the bottom one by 2 to get 12x plus 6y equals 4. We can now add these equations together to eliminate the y value, giving us 21x equals minus 14. This means that the x value is minus 14 over 21, which is the same as minus 2 over 3. Again, we now need to sub in our value of x that we have found to find the y value. So I've chosen to sub it into the equation 6x plus 3y equals 2. 6 times minus 2/3 plus 3y equals 2 is minus 4 plus 3y equals 2. Meaning that 3y equals 6, and therefore y equals 2. Also remember that you can always sub back in your values that you have found into the original equations to check that your answers are correct. Here's 2 questions for you to try. Press pause and have a go at them, and press play when you're ready for the answers. Moving on to quadratic simultaneous equations, these are simultaneous equations with one linear and one quadratic equation, which can have up to 2 pairs of solutions. You need to make sure the solutions are paired correctly. For this example, 2x plus y equals 1 is the linear equation, and x squared plus y squared equals 1 is the quadratic. To solve these equations, you need to rearrange the linear equation to make it y equals or x equals and sub it into the quadratic. So for this example, I need to rearrange 2x plus y equals 1 to be y equals 1 minus 2x. This can now be subbed into the quadratic equation, so in replace of a y, there is 1 minus 2x. This needs to be multiplied out, so it's x squared plus 1 minus 2x minus 2x plus 4x equals 1. Adding all of this equation together would be 5x squared minus 4x, and taking 1 off of both sides will mean it's equal to 0. Factorising this gives x brackets 5x minus 4 equals 0, meaning that x is either equal to 0 or equal to 4/5. We now need to find the y values for this set of equations. So to do this, we need to find what y is when x is 0 and also when x is 4/5. So subbing in x is 0, 2 times 0 plus y equals 1, which means when x is 0, y must be 1. When x is 4/5, 2 times 4/5 plus y equals 1, meaning that y equals minus 3/5. So here are the two pairs of solutions for these simultaneous equations. Here's one for you to try. Press pause and try it, and press play when you're ready for the answer.